Hey guys, welcome back to another lecture. In the last video, we learnt about muscles of respiration and movement of thoracic cavity, right? Now we move on to the respiratory pressures for today's topic. So basically when we talk about respiratory pressures, we come across two pressures, that is intrapleural pressure and intra-alveolar pressure. Intrapleural pressure, it is also called as intrathoracic pressure, whereas intra-alveolar pressure is also called as intrapulmonary pressure. One by one, we will know what are these and what action do they have. Intrapleural pressure. The name itself suggests the space in between the pleura. Intrapleural pressure is the pressure existing in pleural cavity, that is in between visceral pleura and parietal pleura. In both these layers, in between them there is a cavity which is called as pleural space. This space has a normal fluid called as pleural fluid. This fluid acts as a suction. Okay, when we always heard in the last video that intrapleural pressure is always negative. Do we mean -1 by it? No. It's not about minus or plus in this actually. It is in relation to the atmospheric pressure. Respiratory pressures are always expressed in relation to atmospheric pressure, which is 760 mm of Hg. So generally atmospheric pressure means pressure in the surroundings. So this is around 760 mm of Hg. When we compare our respiratory pressure to this 760 mm of Hg, if it is less than that, it is called as negative. If it is more than that, it is called as positive. Negative does not mean -1. It means it is less than our atmospheric pressure. Now we come to the normal values of each and what action or what pressure changes happen during inspiration and expiration. First we come to the normal inspiration. At the end of normal inhalation, pressure is -6 mm of Hg, which means it is 6 mm less than atmospheric pressure, which means what? 760 minus 6, which is equal to 754 mm of Hg. At the end of normal expiration, we have -2 mm of Hg as the pressure. Means what? 760 minus 2, which is 758 mm of Hg. Now we come to measuring how this measurement is done. So basically there are two methods, direct method and indirect method. In direct method, the intrapleural pressure, it is determined by introducing a needle into the pleural cavity and connecting it to the mercury manometer. By this, the reading is done. That pressure is our intrapleural pressure. Whereas in direct method, the esophageal balloon is inserted into our esophagus and this pressure is considered equivalent to our intrapleural pressure. Now we come, what does this intrapleural pressure actually do? It prevents the collapsing tendency of lung, is respiratory pump for venous return. So that was about the intrapleural pressure. Now we go to the intra-alveolar pressure. Intra-alveolar pressure existing in the alveoli of the lungs. Intra-alveolar pressure is equal to atmospheric pressure, which is equal to 760 mm of Hg. As it is in connection to the environment, the pressure here and the pressure outside is equal. Now what happens to this pressure during respiration? This is when we are at rest, there is no inspiration or expiration, our alveolar pressure is equal to atmospheric pressure. Whereas when we are breathing in, the pressure becomes minus 1 mm of Hg. Again here, minus 1 doesn't mean it is negative, it means less than 760. 760 minus 1, it is 759 mm of Hg. This light negative pressure pulls the air into the lung. As we saw here, we need some pressure so that air comes into the alveoli. That pressure is created by this intra-alveolar pressure during inspiration. Now at the end of expiration, the pressure it returns back to 760 mm of Hg. It goes to negative, but it comes back to positive during expiration. Now for the measurement of intra-alveolar pressure, we need an instrument which is called as lethosmograph. Lethosmograph is a test which is used to measure volume of air in the lungs, including the air that remains after full exhalation. That is our residual volume. Heard about spirometry? It is also used to measure the volume of air in the lungs, but it does not calculate residual volume, whereas lethosmography also measures the residual volume. So basically it is like the person sits in an airtight box like a body lethosmograph. They breathe through a mouthpiece that's connected to a machine. As they breathe in and breathe out, pressure changes in the box and in the lungs are recorded. These pressure changes are used to calculate lung volumes using Boyle's law. Now what is Boyle's law? Boyle's law is a basic principle in physics that explains how pressure and volume are related in gases. Now at a constant temperature, pressure of the gas is inversely proportional to volume of the gas. Whenever the volume increases, pressure decreases. Whenever volume increases, pressure decreases. How this works in the lungs? When you inhale, your chest cavity gets bigger. So lung volume increases and pressure decreases. That's why air is flowing in. But when you exhale, your chest cavity gets smaller. So your lung volume decreases. So pressure will increase. So which will help in air moving out of the lungs. Okay, let's move on. Why are we actually studying this pressure in the first place? So what is the first significance? Intra-alveolar pressure causes flow of air in and out of the alveoli. During inspiration, the pressure becomes negative. During expiration, it becomes positive. Intra-alveolar pressure also helps in exchange of gases between the alveolar air and the blood. Because of this pressure, the exchange takes place. Transpulmonary pressure, it is the pressure difference between our intra-alveolar pressure and intrapleural pressure. If you are subtracting the alveolar pressure from the pleural pressure, that is our transpulmonary pressure. It is positive, which keeps the lung expanded. Compliance is the ability of the lung and thorax to expand and expansibility of the lung. So basically remember the word expansibility. It is defined as change in volume to per unit change in pressure. So what happens? How much change in volume upon change in transpulmonary pressure? That much is the expansibility. Increased compliance means lungs can stretch more, and decreased compliance means lungs are stiff and hard to expand. Compliance is related to two principles: elasticity and surface tension. Elasticity is the stretchability of the lung, thus increased elasticity increases the compliance. When we come about surface tension, is the tension in the alveolar surface. This tension is not good because it has the tendency to collapse our lung. Of surfactant, this does not allow surface tension to act upon. So more surface tension, less compliance. Less surface tension, more compliance. Means more expandability. So that was it for today's video. These are some of the references which I've used to make notes and to teach this video. Hope this was a useful video. Please make sure to like, share and subscribe. This is really helpful for us, and if you want notes of this video, it will be posted on our Instagram page, which is at Easywezy _. Have a nice day. We'll meet you in another video.